Hello, everyone, and welcome.
Today, we're going to take a closer look at an exciting project built to showcase how microservices work in action.
It's a hands-on example that brings together multiple services, databases, and system components, all tied into one complete application.
Another thing is that it's actually his very first attempt at building with microservices. Even though it's a learning project, it's surprisingly detailed and covers almost every major piece of a modern microservices architecture.
At its core, this project is a password vault application, which means users can create accounts, log in, generate strong passwords, store them securely, and even upload files into their vault.
Now, instead of being one big application, everything is broken down into independent microservices.
Exactly. Each service has its own responsibility, and usually its own database, which makes the system modular, scalable, and easier to maintain.
Let's start with the authentication service.
This one handles user registration, login, and session management. It stores all user credentials securely in its own PostgreSQL database.
Then we have the password service. That's where the vault itself lives. It's responsible for storing encrypted passwords and also generating strong passwords when users request them. Just like Auth, it uses a separate PostgreSQL database to keep things isolated.
Next up is the file service.
This one manages file uploads and downloads. Instead of a database, it stores files directly on the file system while saving file metadata so everything stays organized.
And we can't forget about the front-end service.
Built with React, it gives users the actual interface, logging in, accessing the dashboard, generating passwords, and uploading files. It supports both light mode and dark mode for a smooth experience.
Now, let's talk about how these services actually work together. The first piece is the API gateway.
Think of it as the single entry point. All front-end requests go through the gateway, which routes them to the correct back-end service.
Then we have the load balancer.
This ensures that traffic is evenly distributed between service instances. So if one instance of the password service is busy, the load balancer sends requests to another healthy one.
To make sure services can find each other, there's Eureka Service Discovery.
Instead of hard-coding addresses, each service registers itself with Eureka. That way, the gateway or another service can simply look up the correct address dynamically.
For managing configuration across multiple services, we have the config server.
Exactly. Rather than keeping configuration in every service separately, the config server provides one central place to pull it from.
Then comes monitoring and observability.
The project integrates Prometheus for collecting metrics and Grafana for visualizing them in dashboards. This helps track performance, resource usage, and system health.
But monitoring isn't enough. You also need tracing.
That's why Zipkin is included. It lets you see how a single request flows across multiple services, making it easier to debug bottlenecks or failures.
And finally, there's centralized logging.
Instead of logs being scattered across different services, they're collected in one place for easier debugging and analysis.
Let's quickly recap the storage setup.
The authentication service uses PostgreSQL for user data. The password service uses another PostgreSQL for storing credentials. The file service uses the file system for actual file storage, and Redis is included for caching and managing sessions.
Now, from the user's perspective, it's all very simple.
Exactly. First, you open the app and register or log in through the Auth service.
Once logged in, you land on the dashboard.
From there, you can generate strong passwords automatically or create custom ones. You can also save them securely to your vault.
You also have the option to upload files, which are stored safely through the file service.
And all of this is tied together seamlessly by the front-end and back-end services communicating through the API gateway and load balancer.
So, to sum it up, this isn't just a password vault.
It's actually a complete microservices playground with authentication, password management, file handling, an API gateway, service discovery, load balancing, centralized configuration, monitoring, tracing, and logging.
And the best part is, this entire system was built as a first attempt at learning microservices.
Exactly. A secure, functional, and scalable password vault application.